Hello everyone, welcome to the motor design platform. In this video we are going to discussing about the types of the rotor surfacing. So let's see step by step. This is our focus content. That is rotor surfacing. There are three types of rotor surfacing. Surfacing with the help of spline function, 2-arc surfacing and the 3-arc surfacing. There are various advantages to use rotor surfacing. It reduces harmonics in the air gap flux density and the back EMF and reduce the cogging torque, improve LD by LQ ratio, and enhance field weakening capability. Let's proceed. Here are the input parameters that you have to provide. So let's provide. And we have to check whether they are consistent or not. All the values are correct and consistent. So let's proceed to on the next stage. Here we have to select the different materials of the motors. So let's select them one by one. Rotor material, and finally permanent magnet material. Again we have to check or material consistent and valid. That's the flux density, the different part of the motor. So these are the value for the different magnetic flux density in the different regions. Okay, let's proceed to the next. Here we have to select the type of motor. I have selected the IPM ISM motor. Okay, and proceed. Here again some input parameters that you have to provide. So let's provide them and check whether they are consistent or not. Yeah, of course, these are found to be consistent. Let's proceed to the next step. Here are the electromagnetic parameters that we provided. So let's select those default values only, suggested value that we have obtained from the algorithm, and proceed to the next. Here we can see the different laminations of the regions. So let's see. Here is rotor lamination, these are the dimensions. Here are the slot lamination parameters. Okay. Here are the rotor dimensions also along with rotor. We can see the magnet parameters. Similarly, we can see for the separately the stator and the rotor laminations. Okay. So default motor design, proceed. Here I provide the type of bindings. So I have selected double layer binding and proceed to the next. This is the default double layer binding scheme that we have got from the software. In corresponding table represent the different factors: coil pitch, binding factor, distribution factor, pitch factor, and slot per pole per phase. We can also see the EMF polygon. This is the default EMF polygon for the double layer binding that we have seen earlier. Okay. Now proceed to the next stage. This is the default slot. So we don't want to manipulate it. We can simply proceed. Here we have to provide the types of rotor surfacing. That we are focusing. So let's select the first one, spline surfacing. Okay. So these are the input parameters for the rotor surfacing with spline functions. Okay. We can also see the alignment d-axis alignment. Default it is d-axis alignment, but we can change it to q-axis alignment. Okay. This is the overview of the q-axis alignment. Now go to the 2-arc surfacing. Proceed. These are the three inputs for the 2-arc surfacing: offset, control, and alignment. You can see the description of control, offset, also the alignment. Default is d-axis and we can change it to q-axis alignment. Okay. Now move to the 3-arc surfacing. These are the parameters for the input parameters for the 3-arc surfacing: offset 1, offset 2, arc 1 spread, arc 2 spread, and alignment. You can see it see here properly now. Okay. Also we can change the axis to dxq d-axis. Now let's move to the spline surfacing, and we will go with this design only. Spline using a spline function. Let's proceed. Let's give the input. Minimum air gap, 0.8, maximum air gap, 2 and alignment, and we can consider default only, D-axis alignment. Okay. This is the calculation of slot leakage inductance, magnetizing inductance, slot area, number of turns. Also, we are able to compare both the things simultaneously for spline rotor and the circular rotor. We can also see the variation in the calculations. Magnetizing inductance coming slightly lower in the spline. So we can proceed to the next. Here we have to select the parameters which we want to analyze. So let's select the first two parameters and proceed. So this is the waveform for the cogging torque, and these are the values after surfacing and the before surfacing of the cogging torque. We earlier said that we will do this, but already these values are in millinewton meters, so we won't bother about that much about it. Let's move to the back EMF, and this is our back EMF, which is coming slightly smoother than the round rotor in this video. Also, we can see it from here. Total harmonic distortion after surfacing coming slightly lower than the round rotor, and also distortion factor is also increased in this, so it's pretty good. Let's go to the harmonic content. This is our harmonic content after surfacing. We can see here that fundamental magnitude is greater, and 12th order harmonics is dominating in this. Let's see the harmonics before surfacing. Here we can see the harmonics that 11th harmonics is dominating earlier, but on the after the surfacing 12th harmonic is dominating. So we can see there is an improvement in the harmonic content. So this is what about the surfacing in this video. So let's end this slide. Thank you everyone.